Chapter 3.2 Quick Review, Exercise 1 through 10. This is the section 3.2 on modeling using exponential and logistic functions. And so this quick review is a prelude to that process. And we're going to look through the odd number problems here. In exercise 1 and 2, convert the percent to decimal form or the decimal form into a percent. And so we have this 15%, and the meaning of 15% is 15. Percent comes from the French word pour cent, meaning per 100, for every 100. So 15% equals 15 divided by 100. And to perform that arithmetic, it's like to divide by 100, we move the decimal places here, in a base 10 number like 15, 2 places to the left. So we move 1 place, 2 places. And so our answer is going to be 0.15, or we can just write it like 0.15. And basically the concept here is that our formulas for determining exponential growth or decay, we have to change percentage into a rate. So this is a crucial skill to be able to do this. And now problem number 2, we have a rate. We want to change this rate of 0.04 into percentage by, instead of dividing by 100, in this case multiplying by 100. So 0.04 is going to be 0.04 times 100. So that's just to look at problem 2 briefly. Problem 3, show how to increase 23 by 7% using a single multiplication. So what this basically refers to is that if we have a starting amount of something, we could be a sub 0, which would be, so sometimes you see that little 0 subscript means starting amount at time equals 0. And we have times 1 plus our rate, and then to the power of time, whatever that is. All right, so our rate, this r here, is what we call our rate in this basic exponential type relation formula. It's going to be not in a percentage, but as a decimal. So we have to take the 7% and change this to a decimal, which is very much related, is it not, to what we did here in problem 1. We changed that 15% to a decimal. We're going to change this 7% to a decimal. To do that, we take 7 divided by 100, and that's going to be equal to 0.07. And so using the formula here, we have a sub 0, which is our starting amount, which is 23, times 1 plus our rate, which is 0.07, to the power of t. Well, t will be just 1, so I don't even put an exponent there. So our answer is going to be 23 times the sum of 1 and 0.07. So 23 times 1.07. That will be our answer to problem number 3. And problem number 4 is how to decrease. So what you're going to have, in this case, you're going to have 1 minus r for a decrease. Or you can say 1 plus negative 4%. So that's how you take a look at 4. In exercises 5 and 6, solve the equation algebraically. So we have our equation, which is 40b squared equals 160. And to isolate b, we're going to divide both sides of this equation by 40. And we have a cancellation, so b squared is going to be equal to 160 divided by 40. We can cancel out the zeros. We're left with 16 over 4, which is 4. So to solve for b, we take, to cancel out that squared, we take the square root of both sides of this equation. We end up with b equals the square root of 4. What's the square root of 4? 2. Now, is this our answer? No, this is b equals 2 is a partial answer. Our complete answer is going to be found by taking plus or minus 2. And why is that? Because if b up here in b squared equals 4, if you take b equal to negative 2, okay, negative 2 squared is going to be 4, just like 2 squared equals 4. So when you have an even numbered root, you're going to have a plus or minus answer. Okay, problem number 7. In exercises 7 through 10, solve the equation numerically. Well, to do that, I'm going to rewrite this. 782 b to the 6th equals 838. And to solve this, we divide both sides of this equation by 782. 782. So we have b to the 6th power equals 838 divided by 782. And to undo this this power of 6, we take the 6th root. So we take like a radical here with a 6 in the upper left corner. And so b is going to be equal to the 6th root of 838 divided by 782. And so we go to our calculator and we go get the root here, and we put our 6th root of, we come in here, make our division, and we take 838 and divide that by 782, and we get 1.01159. 1.01159. All right, let's do that. Now, did we have an even numbered root? Yes, we did. So as a matter of technicality, we're going to have a plus or minus, because if we take negative 1.01159 and take that to the 6th power, we're also going to end up with this 838 over 782. Okay, and number 9, we have 672 b to the 4th power equals to 91. We do the same thing we did for problem number 7. We divide both sides of this equation by 672. So we have b to the 4th power equals 91 over 672. And to undo the b to the 4th power, we take the 4th root. So in our calculator, we're going to have b equals, and again, we have an even numbered root, so we are going to have a plus minus. So we go to our calculator again, get our control exponent, put a 4th root here, make a fraction. We have 91 over 672. And we should get a number of less than 1 for this. So we get 0.606622. And we know it's an irrational number. We know it's not going to be exact. But it's going to be as close as we can get reasonably possible to that. So anyway, those are the answers, and also the working out of all the unknown problems. Take a look at your even number problems. Good luck with them, and thank you for viewing.